I think. For the tutorial, thank you.
Thank you. So we're going to start at the same landing page as we were yesterday and go to tutorials and start on the second one. One more time around, everybody can use the IC shell. Very good. Did anybody follow the setup instructions for this particular version of the tutorial? No, and that this time it's good because I'm just going to step through them anyway because it's not that time consuming. Okay, first, the question, where do we get simulation campaign output? How to find it and how to get it onto my computer or into my analysis. Those don't need to be the same thing. I think yesterday I already showed like one of those long paths. The main classification is always between event generator, that's Pythia, or eStarlight, or a gun. Full is the JAN4 output before reconstruction. That only exists for select campaigns because it is very space consuming and it's only really useful for reconstruction technique improvements. And what we're going to be looking at today, first and foremost, is RICO, the reconstructed parts. We will use the RICO campaign from last December, simply because that's what was used in this tutorial, and that allows me to copy paste more easily. There are two main ways to get to these files. None of them is really preferred over the other, but the first one that we're going to talk about does not require any credentials for read access, whereas the other one does. It's trivial, but it's something that needs to be. So it's one small layer extra. So I'm going to start in an EIC shell. And I don't quite understand why Docker is always so slow on my computer, but it should come up in seconds. There we go. And the first one is through a protocol called XrootD. Many of you may be familiar with that. It's used in many experiments already. And the main thing is to connect to the right server. And then you can look around there. Oh. You need to know your work, your entry point. That is going to be, it's going to start with work/EIC. What doesn't work here is things like tab completion and what have you. But you see, there's a bunch of stuff here from earlier times when Athena and Core were the pre-collaboration, the proto-collaboration that ended up being joined into Epic. So Epic is the one that we're mostly interested in. Lots of stuff, but as we were talking about, we want to go with the RICO. And specifically, and you see here, it's again the name of the configuration, Epic Crater Lake. For this example, we're going to look at DIS, created by Pythia, neutral current, and highest energy. At what Q squared do we want? A minimum of 10. And then you see a boatload of files. And we can now grab one, select it at random. And we can now exit this browsing mode and use XRD-CP. Grab that file and the destination is dot. Dot is always stands for the current directory, but you can put it anywhere you like. Fantastic. We forgot to add the server location in front. Let me know if that all works hard. But we don't need to do this quite yet. So we can continue with the second method. That is using BNL storage, which is an S3 system, which is more or less what Amazon uses, and it can be accessed with a client called MinIO. There are instructions here on how to install it natively onto your computer, but you really don't need to do that. It's part of EIC shell, and it lives in your path. So you can see that it's there. Yes. What you need to do for this once, writing these down, instead of credentials, you're going to use twice EIC S3 read. So it's and then you have to just configure the host once. This one works a little bit differently because from now on we don't need to use that direct server anymore. We can just use MC ls s3. And as you can tell, all of this dates back from a time when we had not really decided on names and nobody ever changed the names. So we go to EIC test. And you see the same thing. There's Athena stuff, there's local user stuff, there's Edge stuff, and of course we want Epic. Same thing, we could now MCLS our way through here, and then once we select something, we do MC CP, and then this full thing. Where's one? Same difference. There's a slight speed difference, but I wouldn't be able to tell you in which direction. I'm used to the MC version. The officially supported one is XRD, and it helps because you don't have to remember these credentials. Okay, but here's something cool. We don't need to load it online. Because all of these are in the root format, there's a special streaming service provided for these. So you can essentially look at them and go through them online without downloading. Let's do that. We have here, do you remember this XRDCP thing? Instead of XRDCP, we could directly open them with root. And you can now work with this file as if it were on your computer. It's usually useful because bandwidth is a limiting factor. It's not so much a limiting factor when you're doing complicated analyses. And it means that you don't have to fill up your hard drive. There's some, where is that advanced use case? As the author says, we won't be going through here, but the one thing you cannot easily do is use wildcards, so asterisks or question marks. So in order to grab a whole bunch of files, you need to first use more advanced language, like find minus name this, and then for each file that you find like this, you execute copy command like that. We leave this here so that you can use it in the future. It's not a subject we're going to discuss here all that much. So for now, does everybody have a local file? Anybody not been able to download a file yet? I know not all of you speak up when they have problems. I encourage you to do so. Okay, cool. So XRDFS can be used to snoop around in XRD. Then you exit and use XRDCP to get the file. You can do the same thing with the MinIO client MC. And using root, you can also directly stream things. Questions so far on this particular setup? Naming scheme. Maybe worthwhile to take a look at this naming scheme. Because remember, we talked about how Epic wants to be completely reproducible, and it's very important to us. So what we should be doing is use an extensive metadata catalog that's in the works, that essentially for every file remembers what was the generator, what is the statistics, what is the Q square, that kind of stuff. Currently, this is all encoded in the name and the path. So we'll always see the campaign container. So the campaign is directly the same as the container name. You can always download the container with that name and have Epic software as it was at this point in time. We're doing this physics with this min Q square, and there's also a lot of stuff encoded again in here in the actual file name. The beam effects have been applied. That means the crossing angle has been done before running it through Geant4. High divergence, not sure. Oh, I think it has to do with the beam spread, with the energy spread. So for everything else, for the rest of today's tutorial, at least, you just need root. You could do all of this outside of EIC shell, but there's no reason to do it outside of EIC shell. One thing that it helps is that it keeps root versions updated, and you can see this little text here. That was a hiccup a few months ago, where all of a sudden a recent root version stopped supporting backward compatibility. That's been fixed and it now works. But if you're unlucky enough to have this particular root version installed natively on your computer, then things won't work. So no reason not just to do it inside ESC shell. But you see here, this is me playing around before starting this. That's me doing it locally, just because both work. Okay, now you have a root follow. Show of hands, who knows root, who has root experience? A bit more than half. Who is seeing root for the first time? Okie dokie, okie dokie. So root essentially is the main PEP and nuclear particle physics analysis tool. It provides two main things that made it popular. First is trees, which is a good format to store events. Like you have an entry for every event, and that event has leaves or branches. That's where the tree nomenclature comes from. And it's been optimized for storage, for streaming, for all kinds of things. Secondly, it has a rich group of classes for histogramming, for graphs, for you name it. You can do complex math in it. You can do, I think, some machine learning to an extent in it. It supports pretty much all your needs. It's also a pain sometimes. The first thing to do if you encounter a new file, a new root file, is always to open T browser. You just type new T browser. What you're seeing here is interpreted C++. That's also nice. If you just want to play around with some C++ code, you can just fire up your root interpreter and see it in action. I tried today to figure out how to make the font size bigger. If possible, it's not easy, but I think you can mostly see what's going on. It opens, yep.
It doesn't open the TB browser, TB browser.
Try to. Yeah, you need VPN's connection. Are you using it locally or on a farm? Please install exports. So for some reason, the T browser thinks that the most important thing for it is to display your local file system. That's not the case. We really don't care about that all that much. Here is where the root files that you have attached show up. So now these are the contents. You see here the pod.io metadata. That's just some auxiliary stuff that you don't need to worry about. The events is really where it's at. So this is all the data for a single event. So you can see there's, for the B0 detector, there's things in there, various calorimeters, trackers, the riches, more calorimeters. So why don't you go ahead and find the negative end cap ecal and plot the energy clusters. I'll do the same thing for the positive end cap. Once you located what you have, double click on it. That opens the contents. So all of these branches now have leaves. And in there are plain old numbers. You double click on those. And a histogram is created. Now, you see that the choice of axes isn't particularly wise. But in the negative going direction, there's more. Why is that? Why are we seeing this peak here? I remind you, these are EP collisions at 18 on 275 GE.
That electrons that are just completely missing and passing through?
No, that's the clustered electrons.
Sorry.
Oh, that's the scattered electrons. This is the end cap where we're really trying to be like the acceptance is exception. We find these. That's why we need this end cap so much. This is the prime ingredient we need to reconstruct kinematic variables, be it x, be it q squared, and what have you. So what does it do? It essentially searches through all the entries in the entire tree, selects the minimum and the maximum, divides that range into 100 bins, and plots this. Useful for that, but for positive one, well, we did miss the scatter photon. Mostly. it finds very few low energy ones, but there must be one guy hiding here somewhere that offsets the axis. Well, if you right click, we don't want the x-axis, we want the y-axis. Also depends on where you right click. You need to essentially right click on an axis, not on a background. But it doesn't matter which. There you go. This is the grass that confused Root so much that we're showing this. Well, nothing forces us to use this particular histogram. We definitely want to use our own. So what you can do is directly from the events draw what we just identified, ecal, end cap, and clusters. Oh. Else to be in the right shell. I'm closing this browser because I think it's confused. And I probably, we want the energy. Okay, so far so good. It does the same thing, but we can tell it to do it differently. We can tell it to first of all name the histogram differently. By default, it's called H10. We call it H1 and give it 1,000 bins from 0 to just 20. Or there's 10 bits. Why is this not working? Because I don't remember that syntax. There we go. How are we doing so far? Everybody can see something? Everybody can play with the browser? Everybody has created their own histogram with their own bidding yet? Anybody who hasn't? Go ahead. What's wrong? Start. Oh.
Because you know, I found like very dumb question.
I think
How do you create like an array with number from 0 to 1,000 with a step? Maybe this is why step should be 1.
Yeah.
I can access and create it. Step size 1,000 can be step.
Please install exports.
Yeah, I'm just trying like
This command is really powerful and very convenient if you want to first get a grasp on what your data is, what you want to explore. You can also tell it to use, here's a different binning.
This is actually.
And we want to instead draw the Z momentum.
To some I can holistic.
Now let's look at only the Z momentum of electrons, or well, of negative particles. So in the second string, you can give it a condition. And what have we here? These are truth particles again. Yep. Okay. This is now the third person who gets the message that the browser cannot open in batch mode. What I need you to install on the Mac is Xcores. And then you need to reboot your machine. And then you probably need to click on a box and reboot it again.
Okay.
In Ubuntu, you should not be seeing this. Why? I see that because X11 is installed by.
This your message with one much because I used to I don't have them. What at least I can access the file that is scan. Right. First I had cannot display.
Oh God. Root is trying to be too clever. Root has changed to a web browser based format, but you should not be seeing that inside the EIC shell change.
Okay,
Browser. Are you using your native root?
Kind of playing. I use in 2021 for regular weeks.
Then fine.
No, I was going to say, if it's a web browser, you can just turn it off.
Why is it fine? I just because I try to. I didn't work at first, so I usually open a web equals Firefox. But this is what I have by default. Nothing happened when it happens to grow.
Yeah, this means for some reason you don't have X support. I've not seen that.
No, that's right. Yeah. Oh, let's see. Oh, can you do GLX gears?
I don't think that's.
No, GG.
No, it's not installed inside the container.
Oh,
Do you have a local installed root version?
I do have.
You can use that one.
Well, when I exit the CIC shell and open one of the file, then I don't get permission to read it. So
Yeah, that's probably a token issue. You can download that locally, work with the local. Use the XRDCP and use the local copy.
all this is a local copy.
Oh. Idea how to further get better. That's So anybody else have these weird permission problems in Ubuntu? or in Linux currently.
How did you download?
Yes. So first
I think we
went
should
to-
still continue and keep going. There's a bit more to get through.
Oh, that's probably why. Plus, try.
So finally, you can add a third option, a third string for draw options. And I think the most complete example is this particular last line where we want to plot the momentum, the z momentum versus the charge in a two-dimensional histogram with this particular binning. It's important that you remember this particular language. The colon means versus, and versus means the one on the right is the x-axis, the one on the left is the y-axis. That took me a bit to figure out. So you see some kind of cool stuff here. Again, you can see the scale here goes fairly high, but we don't see almost none of it. So best to check this out in z-log scale. Okay. So now what are we seeing here? Truth particles, charge, z momentum. What on earth is this stuff? Anybody?
Oh, there's the number of events, right?
Yes. But what is something that has a charge between -1 and 0?
That's clock, right? Yeah, it's a clock, right?
Correct. There we go. 4 quarks for master quark.
Certainly hope so.
So I think with this particular example, we're going to stop using the draw command. Directly drawing from the T tree is very convenient, but it's not something that you should ever write an analysis or anything. I've done that once before. Not a good idea. One little trick before we end. Remember from very early on, like one of the first commands we used. So now, if I want to replace this, if I got this from like the T browser, via double clicking, and then I need to remember exactly how to spell ecal ncap n clusters dot energy. Instead, I already have this histogram. I know that it's called htemp, and I can get its title, which is right here. And from here on out, I can then copy paste once, got my information from the T tree, and go on my happy ways because I'm excellent at messing up capitalization of these things. So some light homework. Go through the T browser, plot some things, find what you find interesting. Specifically start with the MC particles because those are the things that you can recognize the best. And then look maybe if you can identify all of the detector subsystems. One more important thing for the MC particles, first of all, the PDG code. I assume that most of you know what a PDG code is. It is essentially 11 for an electron, 12, 13 for a muon, that kind of thing. And the status code, the generator status. As you can see, there were a bunch of quarks in there. Nobody wants to plot against quarks. That's not really what in a physics analysis happens. There is a status, and you're generally only interested in the status full 1. Status 1 is the final state particle, so that's one that reached the end of its showering and then got propagated to Geon and got reconstructed. Stimulator status, not generator. Oh. Generator status is the one that's more important. So how did all of these three branches come to be? Well, remember we talked about, so first of all, the MC particles branch, of course, that goes in there from the generator and gets propagated through Jant, and remember. And then we talked about EIC Recon after that, or I mentioned EIC Recon. EIC Recon has a bunch of plugins. Every plugin can add a collection of things. It can add a collection of ecal cluster hits. It can add a collection of reconstructed charged particles, add a collection of charged jets, and what have you, depending on which plugin you go through. Yeah. Not now, but take your time to explore what's in there. And see how far we get with the other way of doing things. What you really want to do eventually is you don't want to handcraft one-liners that you keep in some kind of logbook and copy paste into the interactive loop window. You want to write scripts. So those are then line by line executed by the interpreter, and they can even be compiled for better performance. So for this, before we get to there, any questions? How are things looking with X course? You two are having any success here? Okay. What maybe?
Yeah.
Want that?
Good.
Okay.
Hey. Yeah, you just enter number and one. Here.
I love tutorials.
Oh.
Yeah, you just enter one.
Awesome. Just maybe I will do the one I have in mind. Course. Kind of want to show. No, and super advanced physics. Oh, this I think it's. But,
Did you say thanks to Melissa?
oh. I thought it was.
Yeah.
Actually, it how I.
This is just showing appreciation, not like I appreciate people work all the time. Not just for the summer school.
Okay. But you should be able to follow along with doing things that do not need the T prep. So pretty much done with it. Hopefully, plots will work. Okay, so open your favorite browser, code editor. Remember to do this in a different directory, not so inside the EIC shell. Use something native and fast. And we're going to call this file jack analysis. it's of course empty. So I assume you have some familiarity with C++. Anybody not familiar with C++ at all? Okay, so the main thing, if you execute a root macro, what it, the function it will by default execute is the one with the same name of the file, not main, so no in main void or in main CRV, but this kind of thing. It has the same name as the macro file itself, so that's the important part. And we're gonna give it a T string. All of the classes, or at least all of the classes from before 2020 in root start with the T or reasons. And T string is essentially just a thin wrapper around a standard C. It has standard C string. It has some nice functionalities. So the in file is of course the one that we just downloaded. And then the body of a function, starting with some boilerplate. So you want to, of course, save your histograms to a file. And so that means starting with opening a root file or writing. That's what the recreate means. We will do stuff. And then just write every object that we created. That's taken care of automatically. Root remembers when you create a histogram and puts it essentially away for saving it. Let's fill it with things. We want something for reconstructed particles and truth particles because we are going to want to make a comparison. So that means we want the status of the truth particles, and we want particularly this one is for momentum track efficiency, I think. The way you read from a tree varies. There's multiple ways to do it. This is one of the more convenient ones using a T-tree reader. So the first thing you're going to do is create a chain of root trees. That can't be just one. But the nice thing is you can add more files to it. So we know that the tree inside was called events. That was the T browser told us. So now we want to add root files to this. Oh. Oh. Thank you, Copilot. For those of you a little bit not familiar, it is very common to use these objects as pointers only. So you get stars, you get new operators typically, and you get the arrows. It's not necessarily so, but from the moment that you derive from anything, it becomes very useful because your TH2D is derived from a TH1D and so on and so forth. Now comes the trick. So we can run this, by the way. It will do absolutely nothing. But if you want to execute it, sorry, I keep getting to my own work directory instead of a separate tutorial one. Okay, let's run it. Aha. finding the first errors. What is it complaining about here? That it doesn't know what an O file is. Oh,
You reinstantiated the variable.
yes. Wrong copy paste. As you can see, it just did nothing. It executed this procedure, but otherwise did nothing. But I can promise you that it does. In case you're wondering why I do the -L, that is motor muscle memory. Because on every installation that I've used before, root starts with a long splash screen that nobody's interested in, and the -L suppresses it. It is not needed. Okay. So now to the meat. As I said, we need a reader. We will tell it what branches we would like to read, and then we can run over it by telling it, give me the next event. So in this case, we want the generator status and the X momentum. And you tell it that the generator status is an int, and this is a float. This will create essentially an array of floats and an array of ints. And every time you make a next, it will be filled with the entries from the tree. So let's run over something before we go any further. We're going to run through the tree. Let me copy paste this and then walk you through it. So next we'll return false when we're at the end of it. Good. For every event, we're going to go through the number of particles. You know what? Let's not even go there. I love how Copilot just wants to fill in the solution for me. But what's the error here?
Using closing braces.
No, that's the same. Maybe I didn't save. Yes. So you see what happened here? I just asked it essentially to print the number of particles in the event. So this is however many thousand events are in this event, and for everything, it prints out, okay, here were 47 particles. But now we want to do something. Go ahead, Copilot, tell me what to do. Thank you. I should turn off Copilot. So first of all, these will always have the same size. They have to have the same size because all of these attributes belong to the same particle. So it doesn't matter if you go through part stat get size or part momx stat size. So first of all, we want to only use final state particles. And then we fill a histogram with the particles. So since you already decided that I want to have an H1 momx, dear Copilot, tell me to do that. Thank you. I can only recommend Copilot for the ridiculousness of it. So here we create a new histogram of momentum, good name, from 100 bins from -10 to 10. Let's see if that is a wise choice route. And yes, drawing would be great, thanks. Okay, so it did create nonsense. Oh, no. So you see that we are getting the correct output from the events, but just for some reason doesn't quite trigger here. I'm open to suggestions. I cannot see very well what I might be doing wrong here. Oh, I know. This is extremely convenient to write and to close. But the moment that you write and close, the histogram vanishes from memory. Thank you. Even the axis choice is fairly reasonable. So here you go. This is generated X momentum for final state particles. Not really what we're looking for, but a nice demonstrator on how to plot these things. Questions so far? The basic flow clear. You get this reader array, you run over all events, and in an event, you then can cycle over the particles or the jets, if you so chose, and do things with them. Histograms, you define their official name, their title, the number of bins, and the ranges. And once you have a number, say, here was a particle with an X momentum of minus 0.45534. If you tell the code to fill the bin, it will look up in which bin falls minus 0.415534 and increase the content of that bin by 1. Now let's add reconstructed particles. First of all, we want more from the MC particles because we want the full momentum. So why don't you tell me what I want? Yep. Correct. And then we want the same thing for the reconstructed particles. Nope. Now you guess wrong. So first of all, you need to find out what the name of these is. So for that, you were in your trusty browser and browsed until you could identify something that would correspond to what you're interested in. In this case, reconstructed charged particles are what we're looking for. You know what? It's getting late, so why don't we just do this for reconstructed particles? It overrides by default. Not a problem. So quite different, which is to be expected, because the average detector isn't perfect. What I want to talk about tomorrow is how to relate the reconstruction, the truth with the reconstruction. Those will be associations, because this is important. I mean, you have however many truth particles, not all of them will be found. Some of them might even be replaced by ghost particles. So if you want to do any improvements on your reconstruction, any improvements on your entire chain, you really need to know what belongs to what. And I think I'd like for you to get to exactly this point or something similar today, and otherwise we're done. So if you have something right now, that's great. If not, I will just walk around here and see what's up.
They just did triple. There's double. It's hybrid, yeah. They had double for the.
I'm doing that right now. I just assumed that the XMD would work straight out of the box,
Yeah.
but I think it requires EIC shell.
I'll try that. Thank you.
The S3 version should work, but for that, all working?
Yeah, actually, I did this.
I figured you'd be more of a
Final typing.
years than
Yeah.
a student.
Just, yeah, and plus he's got fixed.
One nice type.
Yeah.
What's the actual problem? Some exposed.
No, it's because he runs the EIC shell through sudo.
To that.
Yeah. So then it was just a matter of changing the permissions.
Mm-hmm. Show of hands if you have something showing, have some progress. Okay. Be here all night.
Directory,
Yeah,
there's a space in the name, which means to tab complete, you first put a quote. And then start typing. So I just spent like 20 minutes and I couldn't find this directory.
Ah. Yeah, it's good. Does that do the trick? Okay, I'll give you one more take home homework for extra credit. Just for the MC version. What's Q squared? How's Q squared defined? Yeah. Calculate the plot that. What is the incoming particles for momentum? Yes. This is all on shell. We're doing collider physics here. So no action by momentum. What's here? for this particular file, 18 on 7 through 75 GeV. So what you can do without, like, this is completely, I mean, we're neglecting mass here. What you could do is just search through, or you can do that for reconstructed electrons or for truth electrons. Just search through the entire event. Every electron is a candidate. At this point, we have to assume that. So take use all final state electrons and compute that thing and plot it compared to the truth square that actually exists in another field. I just feel like what we're doing here is essentially currently doing things like efficiency analyses, resolution analyses, but you can easily do physics right away. All of these things. Aren't you free after one of these? I'll hang around for a little bit. That'll work. Yeah.
I prefer to do it. Want to. I normally resize Windows.
My virtual bugs that I'm using ran out of memory. And I need to resize the partition, but it won't let me resize the partition because I'm using the partition. And I'm trying to figure out how to do this so that I have enough memory to do these things.
You can delete them.
Oh, I don't think so. I don't know. I give it twice as much memory. I have enough memory. I just now need to take the partition and extend it into the new memory I gave it, and I don't know how to do that.
Might not be the exact same file. Just download the one that you have there. Yeah.
So, using the USB. Oh.
Like so. Download this.
And finally see where. Right. Oh, John. I don't know. I see.
No, no.
Oh,
Just
Ah, no,
Yeah.
no, in realtà io non
Ci sta, ci sta. Ci sta, è uno stabile legato che è strettamente legato a QT. Se tu esplori quella definizione lì, la scrivi in funzione dei QT, ti viene che per piccoli QT è circa QT su M.
Ah, ma
Skips would be the skips. Ah. So on this side.
yeah. Oh, that's very cool. Actually. ChatGPT get quite good. You just have it like.
Yeah, I have an account. It's free.
Oh, gotcha. Oh, right.
Actually, I actually use it as titles.
Mm.
You know, but gave me
Pure tale che tuo QT dello Z produttivo non si perco automaticamente nell'osservazione. Cioè, come si genera questa
external astronomy. But I put in keywords and it came up with stellar legacy. You know, astronomy, stellar.
Yeah.
It was actually kind of cool. Trust but verify, but
Yeah.
yeah.
And that's why NVIDIA is rolling. They are rolling like crazy.
fare male che troppo. Try to like around this road. And on the wrong patch road.
Taking a cipher tomorrow. Just now taking a cipher tomorrow.
Oh, okay. No, I'm not thinking. Total an hour. And 5 minutes plus 15 minutes of question. I know when they gave me this, they gave me the topic on Friday.
That late?
Yeah,
I should not be allowed.
I know.
Ask them like earlier.
Today?
Yeah.
No, I mean, no one even knew it was actually happening. And then today, they, yeah, because I asked them like 2 months ago when they first said they wanted to do this. I was like, hey, what do you want me to speak on? And they didn't respond up until.
That's terrible.
It is. Why do you think I was so pissed yesterday?
Ah, I think